Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to continue looking at AP Precalculus. This is not the first webinar we've done in 2025 on AP Precalculus, and I don't think it's going to be the last. So if this is your first time joining us, later on I'll share a link with where you can look at some other AP Precalculus specific webinars that we've done and ones that we're going to be doing in the future. So tonight we're going to be focusing on the other trig functions and the inverse trig functions too. So I'm looking forward to this. My name is Mike Houston, and I'm the moderator for this event. I teach algebra, calculus, and chemistry near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And tonight, I'm really excited to be joined by Vicki Carter and Rachel Gorsuch. Vicki recently retired after teaching high school math for 46 years at West Florence High School. She's a former co-chair of the AP Calculus Development Committee and is currently serving as an AP Pre-Calculus consultant. She received the T-Cube Leadership Award in 2015 and has served on TI-Nspire authoring teams and has presented at many national, state, and local conferences. Vicki, it's great to have you with us.
Good evening, everybody.
And Rachel's been teaching for 18 years at Tays Valley High School in Asheville, Ohio. Her inspiration comes from asking students, when are we ever going to use this? And Rachel uses technology and mathematical modeling to help her students investigate this question regularly. So Rachel, it's great to have you with us as well.
I'm glad to be here. It's going to be a fun night.
All right, so Rachel, tell us what we're doing tonight.
So we want to get to know all of you. We're glad that the chat is hopping. Vicki and I are going to be asking lots of questions tonight. So we want to encourage you to keep up with the chat. We're going to be using the transformation app on the TI-84 and some sliders on the Nspire today to try to understand better what's going on with these other trig functions. We'll also be doing some transformation with these trig functions. We also want to take a little time to talk about the AP test, and especially that free response question 3, which is geared towards sinusoidal functions. And then at the end, we'll have our closing, and we will not forget that webinar drawing. We know that that's a big deal. We want to get our technology.
Thanks, Rachel. And Vicki, what can we expect to be able to do at the end of the webinar tonight?
Okay, that we want to make sure that you know how to do transformations of those other trig functions, not just sine and cosine. So we're going to work with those on both the TI-84 with the Transform app and the TI-Nspire with the sliders. Again, we want to make sure that you know how to explore those, that application, and can not only work with the transformations with the other trig functions, and I hate to keep calling them that, but if you look at the CED, they are kind of separated from sine and cosine, and also the inverse trig functions, and that we can explore. I think we're going to look more at FRQ4 than we are going to look at FRQ3, so just a little bit there.
Thanks so much, Vicki. And as I think Rachel already mentioned, the chat window already has a lot of comments in it. So thanks so much for everyone that is introducing themselves. We are going to be using that chat window tonight a lot. So if you have any questions at any time for Rachel or Vicki, use that chat window. It works really well. We'll try and get your questions answered live. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So Vicki, I know we have a lot of stuff to get to tonight, so it's all yours.
Okay.
Vicki's kind enough to run all of our PowerPoints, but Vicki, while you're pulling those up, I want to tell you there's a lot of love in the chat right now for you and all the work that you do on the Facebook group. So I just wanted to make sure that you got a chance to hear that before we get too far into the webinar.
Well, thank you. So there are our emails in case you ever need to get in touch with us. If you want to jot those down and again, you can go back and watch the video and see these later if you need to as the recording. All right, Rachel.
So we're going to be talking a little bit about Unit 3 in the CED, which is the trigonometric and polar functions. And we specifically wanted to hit on the tangent function and the inverse trig functions tonight, as well as the secant, cosecant, and cotangent functions. We want to show you where you can find those on the calculator. And also, like, how can you get students to start thinking about these functions in a way that they relate to sine and cosine functions? And just for your reference, if you're not an AP pre-calc teacher, first of all, we're glad you're here anyway because we can all learn from each other about all of these functions. But students in this course have already covered transformations of functions in Unit 1 and 2. They've already been talking about sine and cosine function values, and they've been talking about these graphs. So when Vicky and I talk about the topics today, we're assuming that's previous knowledge for our students.
Definitely. And working with that sine and cosine function transformation sort of separately and what we fondly think of as the first half of Unit 3 really makes a difference for how students accept the transformations and the graphing in the second half of Unit 3.
Absolutely.
So Rachel, before you get started, I just want to say this. If you have your calculator at hand, whether it's your TI-84 or your TI-Nspire, you may want to have it right there or go back and watch the video later and go through some of the things that we discuss. Okay, Rachel.
So one of the things we just really want to make sure that people know about the AP Pre-Calc course is that your calculator needs to always be in radian mode. That is the language of AP Pre-Calc. And so if you have students who are also taking physics, knowing how to go back and forth between the modes in a quick and efficient way is definitely an asset for you and your students. So on the TI-84, you'll go through the mode screen, and you see those key presses that Vicky has so graciously put up on the screen for us, and you can just toggle back and forth between radian and degree. As long as radian is highlighted, then it has been selected. The TI-Nspire actually makes it, in my opinion, just a little easier. In the upper right-hand corner of the TI-Nspire screen, there is RAD, and when you click on it, you can switch to DEG, degree. So just by clicking on the word radian or clicking on the word degree, you can toggle back and forth between those two. So your students who are in physics, no fear, we can quickly get between the two modes.
Just have a constant reminder that they need to be in radian mode, not degrees, when they come to AP, either pre-calculus or calculus. Okay, some differences between the two calculators. On the TI-84, there are dedicated keys for sine, cosine, and tangent. And then all you have to do is press your second and then sine to get the inverse sine, inverse cosine, inverse tangent. Um, there are not keys for secant, cosecant, cotangent. So we're going to talk about that a little bit when we're using the TI-84. With the TI-Nspire, once you press the Trig button that's up under the control there beside equal, you have dedicated keys for all 6 trig functions and the 6 inverses, although in AP Precalculus, we really don't deal with the inverse, cosecant, secant, and cotangent. And by the way, there is a Zoom trig window that is very convenient to use whenever you're doing anything with graphing with either calculator, and we will show you where that is. All right, Rachel, I think I'm ready to go with the calculate. Oops. Okay, so the first thing we're going to look at is the TI-84. So Rachel, you might have to help me kind of go through and decide what it is that we're going to do here. But we want to definitely demonstrate how to graph those reciprocal functions. And so basically that's what students need to be able to do. And so they're going to have to remember those identities about the reciprocal functions. So if I wanted to graph secant x, I need to do 1 divided by, of course, cosine of x. Now, I'm a big proponent of closing parentheses and making sure that I use good notation in the classroom, and so I try to demonstrate that at all times. And so
Vicky,
I'm
I'm
going
going
to
to
go to
interrupt
Zoom.
you real fast.
Oh,
I'm sorry.
okay.
We'll have you switch over and show your TI-84 screen because right now we've got the warm up,
Oh,
but we want to see your screen as you're typing.
thank you. I thought I had changed it, but I guess I didn't.
So as Vicky was saying, one of the big things that we've been talking about in preparation for this webinar is just that we see technology as a tool for helping students make sense of things. It does not replace sense making. And so you'll notice that a lot of the questions that we're asking folks, we're asking you to come up with a conjecture first and then followed up by graphing it on your calculator to test your conjecture. And that's what we want to encourage you to do with your students. Use this beautiful tool as a sense-making object.
All right, Rachel, do I have the right screen up now?
It's still showing your
Okay.
PowerPoint right now.
Okay, I might
On the
have
bright
to.
side, I mean, it's a nice problem. I love this problem.
We'll talk about that one a minute. Let me see if I can.
It sounds
I don't
great.
know what.
So I was talking with my pre-calc teachers in my building, and this was actually a problem we came up with together. We were trying to think, how do you take students from those sinusoidal functions, the first half of Unit 3, sine and cosine, and get them to start thinking about these reciprocal functions instead? And we said that we would probably just give them a graph of a sine function, like 2 times the sine of x, and ask them, what do you think will be true about the reciprocal function? And just see what their thoughts are initially, and then have them start testing some of their ideas. And then that also gives us the opportunity to teach them some of these calculator skills that we want them to have in order to be just a little bit faster, a little bit more problem solving savvy when they get to the AP test.
All right, Rachel, I can't figure it out. So what I'm going to do is stop sharing that and share my other screen.
Vicky's very fancy and has multiple screens.
That I can't use.
There's a TI-84. I love it.
All right, we've got our TI-84. Okay, so probably what I would do first is not what I just typed in. So the first thing that I would do is probably graph cosine of x. And as I was saying, I like to show closing parentheses there. And so let's look at the Zoom Trig window. So Zoom and Trig 7. So notice that we actually get a little more than a negative 2 pi to positive 2 pi window. And so if you don't like that, you could always go into the window and you see that we have this negative 8.6. So if you really want to have 2 pi, you could, negative 2 pi, sorry. Let me clear that. Negative 2 pi. And so to access pi, I need second and the caret key. And then I could go down and change this to 2 pi. And I noticed that I have a very common number here is my X scale 1.57. So I think I will leave it at that. And so we'll look at the graph. And now I see it, what I feel like two complete periods of the cosine function. So let's look at the reciprocal. So I'll go back to my y equals and 1 divided by, and now I want cosine of x. I guess, Rachel, I probably wanted to leave cosine there, didn't I? Let's do
I
it this
mean,
way.
I sometimes leave it and I sometimes take it off. I'm trying to get my students to see the connections between the two.
Okay.
So,
Well, and we can also show you how we can toggle it on and off in just a second. So
oh, that's
1
a great
divided
idea.
by cosine of x. Okay, Rachel and I both are big users of the Nspire, so I sometimes fumble around a little bit with the 84. But I think that's a very good demonstration of what the secant function would look like. And then you could do the same thing with cosecant, and you could do the same thing with the cotangent function. So what Rachel was mentioning is sometimes we like to leave that there in case we want to come back and use it for a discussion with the students. But if you hover over the equal sign and press enter, It's still there as your y1, but when you go to graph, you will only see the secant function.
And Vicky, I love that technique right there because I want them to connect it back to our cosine graph. But I also want them to be noticing things about asymptotes. And I think sometimes when you take that cosine graph away, it's just easier to get a sense of the asymptotes.
Oh, I think so too. And if you wanted to, you could demonstrate that, but I don't think that's really where we are tonight. We want to just show you lots of things that you can do with your students to help them understand these other trig functions and and the and the inverses. And we want to be able to get to the inverses a little bit also. All right, Rachel, is there anything else you want me to do on the TI-84 right now?
No, I think that was a great spot. So as you switch over to the Inspire, I just want to reiterate that on the TI-84, there aren't those quick keys to get to the reciprocal functions. So you actually get the opportunity to think of it as a reciprocal 1 over sine or 1 over cosine of x. So I think that
Yes.
that can be good for sense making, but there are no quick keys on that.
Okay, so do you see the Inspire now, Rachel?
Yep, it's
Okay,
up and
good.
running.
All right. So I typically don't do anything with the scratch pad hardly ever. Occasionally I will if I want to balance my checkbook or something like that real quick. But I'm going to open a new document. So I'm going to go to number 1 and I'm going to, oops, I'm one of those impatient mouse clickers. So I ended up adding a calculator screen. So I'm going to add a graphing screen. Okay, and as we said, these keys are dedicated and they're right under the Trig button here. So if I go to Trig, I have the option of our tangent, our cosecant, our secant, and our cotangent graph. Since we just looked at secant a second ago, we could do that one, but I tell you what, let's do the same thing we did with the TI-84. Let's do cosine of x first. I'm just going to press enter. No, I'm not. I'm going to do zoom with my Windows zoom. So I want to go to number 4. Uh, I'm messing up. Sorry about that. Is my function still there? No. Okay, let's try this one more time. Were we doing cosine and secant a few minutes ago, right?
That's correct.
Okay. Now, when to zoom, number 4, and I'm going to show you where the zoom trig is. It's way down here, number 8. Oops. I told you I'm an impatient mouse clicker. What? Why isn't it showing up? I
A
don't
really
know.
good question.
Cosine of x. Enter. Maybe I didn't press enter, Rachel. I was
I
going too
wonder if
busy
that was
going
it.
to the Zoom. Yeah. All right. So then we'll want to do the same thing. We want to press the tab key. So there's not a y equals key, as you all know, with the TI-Nspire. So I'm going to press the tab key, go to Trig again. And this time I want to go over to our secant. And I've got to put my X and I've got to press it enter, and there we go. And
Beautiful.
it's actually a little bit crisper graph, so you have, a little bit nicer appearance with this. But again, you can toggle these graphs on and off if you want to. Tab is what takes you back to your functions. You would just go up and you could take the check mark off of cosine and then you would just have the secant graph.
That's awesome. Vicky, we've got a lot of stuff going on in the chat. We're talking about the advantage of graphing by hand and graphing on the calculator. And one thing that we wanted to share with everyone is we think that both are really important. Like we want students to understand this for themselves, and the calculator is not to replace thinking. So we just think that this is a great way to explore a lot of things in a very short amount of time. So I think I love all the perspectives that are happening in the chat right now.
Very good. I really, your teachers, I don't think we need to show you each of the other trig function graphs, but we can play a little bit. So I'm going to clear that one. And let's do, actually, I'm not going to clear it. I'm going to leave it in case I want to come back to it. I'm just going to put check marks off of those. I'm going to go back. I'm going to go down to the third graph. Let's show them how to do the sliders here real quick, and then we'll go back to the 84 and do a little bit with the transform app. I would not do a lot of transformations with these graphs, but the students do need to have some experience with some of the transformations. So let's do something real simple like A times, which function do you want to use, Rachel?
We haven't gotten a look at cotangent yet. Can we
All
play
right,
with cotangent?
we certainly can. So cotangent of x, do we want another parameter other than just A where we might be doing that vertical dilation? Do we want to do a vertical shift maybe?
Let's put it in the chat. What do you guys think? Should we add in a B variable as well to play around with this a little bit more? Maybe do a vertical shift? What do you guys think? Raheem
Well, I'm
says
gonna call it
yes.
D.
Like right on it.
Okay. Now, when I type this in, and yes, the Inspire, I just saw the chat pop up on that one. Yes, the Inspire is allowed on the AP exam. So it asked me, do you want to create sliders? And yeah, that was my intent here. Just as a word of warning, if you did not intend to add sliders, then you know you've typed something incorrectly. So, okay, and we get these two sliders and it wants me to move them around. I'm kind of happy with them where they are. That will work. There are variations of the sliders that we could do. So by default, A is 1. Let's change D to 0, and then we have our classic cotangent function. This is just y equals cotangent x. But we could explore this change in D. Okay, and at first it doesn't really look like, these are really good to explore because students may think it looks like something different is kind of having going on. Oh, so Sean just wanted me to change my tick marks. All right, so Sean, I think that's a good idea. Why don't I make that one 1? You know what? I can do magic with this calculator until I get in front of an audience, and then it's like, I don't know what I'm doing. All right, let's do pi over, you want pi over 4 or pi over 2?
He suggested pi over 2.
Okay, so pi divided by 2. Notice that I had to access the pi key over here on the far left, kind of near the bottom. So that's going to put our tick marks at pi over 2, which makes it kind of nice that we can see, well, let me go back to 1 again here. I mean 0, sorry, where we can see where our vertical asymptotes are located. You can move this a little bit if you want. I don't know if I really can't find a good place to put it because there's a lot going on here. Let's just, well, it don't want to go anywhere. I'll just leave it right there. Except it's sitting over top of my pi over 2. There we go. All right, so we've changed D a little bit. So now our graph is doing a vertical transformation upward, or movement upward. Let's go back to 0. Let's change A. So, and honestly, I know Rachel said we wanted to play with cotangent because we haven't looked at it a lot. All right, we saw our reflection there with -1. I really have more fun playing with the secant and cosecant with the change in the A value because you can see that change with that restricted, sorry, well, whatever. The reflection that we have with the reciprocal, you can just see it a little bit clearer and it's kind of nice. Rachel, what do you want me to do now? You want me to go back to the 84?
I would. And while you're switching back to the 84, I just wanted to share because someone said they'd also like to see a horizontal shift on this. It's really the same process to put in one more slider. Is when you're typing all of those values in, you would have just put your x minus whatever variable you wanted to use for your slider, and then you would be set up to do a vertical shift, or sorry, a horizontal shift
Yeah.
instead. So
But I would definitely demonstrate all of these. And I'm gonna go back to something that Rachel said a few minutes ago. I like to kind of do this what if in class. So put in the sliders, or in this case, when we do the transformation app, you could say, I'm going to change A to 2. What do you think is going to happen with this graph? So I think it's important for them to visualize that kind of mentally, even drawing in the air if they need to, and then checking it with their calculator. I'm a big proponent of them having to sketch these prior to checking on the calculator, but let the technology be that. Rachel was talking about when we grew up. I never saw a calculator when I was growing up, but I always called it Bob. The back of the book answers were our guides for whether we were doing work correct. Um, so I see the chat, the different calculators. I think it's what your students are using. I had 84, I mean, sorry, I started with 81s, but I had 84s for a while, but transitioned to the Inspires, preferred the Inspire simply because I feel like it's a very powerful handheld that can do a lot to help students visualize mathematics. But I know that lots and lots of teachers have the 84s in the classroom. So I think it's what you are comfortable with and what your students have access to. All right,
Mhm.
so the
And just
transformation. Oh, what, Rachel?
Oh, no, just one last thing. They were starting to ask questions about midlines and all of these things. You could make a slider for every piece of a sinusoidal graph if you wanted to, and get students noticing and writing down ideas and checking their conjectures. I think that if you have your calculator in your hand right now, I would love for you just to play around with it. Try some of these things out when we're switching away from, like, if you're using the Inspire, try some of these things out while we're doing the TI-84 work. And then feel free to keep asking questions in the chat. This is like such a great chat happening tonight, and we want to encourage that to keep going. Thanks, Vicky.
Oh, you're welcome. So I, I'm back to, I think it's important when you're initially showing students these things, maybe that you do one transformation at a time to kind of help them visualize, because these are going to be really new graphs to these students. They've gotten used to sine and cosine, and then we are adding tangent, and it's kind of by itself, and then the cotangent, secant, and cosecant. But maybe do one at a time, because that screen can get really crowded and really overwhelm them if you try to do too many at once. But I think it's great for you to say, maybe the same thing we did. Which of the parameters do you want to put in? Which one do we want to look at tonight? So the I call these similar applications. It's the transform app on the 84 and then the use of sliders. They're very, very similar. So I've got to go to app, and I know you have seen this demonstrated before with the previous, if you participated in the previous one. So it's way down at the bottom. You could get there quickly by doing the up key. I'll be there eventually. There it is. No, it's not misspelled. That's just kind of the characters that were decided on when this was first put on the calculators. Okay, so let's press enter. And any key, I typically press enter again. All right, so I'm going to clear those out, go to y equals. As has been pointed out in several of the webinars and things that we've done with the Transform app, there are two very different symbols that reside beside Y1 and Y2. So those are going to be your Transform app. Okay, how about we do this, Rachel? We looked at cotangent, we've looked at secant. We could actually graph sine. And do you notice where I am? I'm in Y3 because I do not want this to be a transformation. So I'm going to put sine of X. But then I want to see what's going to happen. I'm hitting the wrong key. All right, go up here to Y1. So with that other symbol, that means it'll be a transformation. So why don't we try, so, yeah, this is actually to me very interesting that students don't understand this. So we want A times cosecant X. So you may want to type in A, oops, sorry, I'm being crazy. You know what I did. All right, A times, and then we would do 1 divided by sine of X. I find it absolutely amazing that students don't realize that that's really just A over sine of X. They don't put that multiplication together. So I would probably type it this way when I'm doing it in class so that it's clearer what's actually going on. Let's just do A right now, okay? So I am going to graph. I think I'm still in the Zoom Trig window. So there we have the sine graph, we have the cosecant graph that showed up, and Rachel, what are those crazy vertical lines that are appearing in there?
There we go. Those are the asymptotes that we've been asking for over here in the chat. So it's great
But
to
they're
see them. And
but they're
this answer, let's go ahead.
no, they're really not though.
Okay.
That's but students will believe they are and be really happy with it. That's in that connected mode. It's trying to connect the last pixel at the top with the pixel at the bottom. And so it's that connected mode. So you would want to play around with this a little bit. But students just are so happy that they think they're seeing asymptotes.
I was too. I should have paid attention when Tom Dick was doing a webinar it must have been last year, and he pointed that out, and I had forgotten about it.
That's
But
okay.
yeah.
It happens. So how do you edit the value of A here in this transform app? Well, you can just hit your up and down arrow, no, your right and left, sorry. Right and left arrow keys. If I had put in more than one parameter, the up and down would let me toggle to the other parameters. Notice that we're not changing anything with the sine function because I did not put that parameter in it. It could be kind of a curious thing to put it in Y2 and have that parameter change with it also. But there are the parameter changes. Well, I went back to 1. I really wanted to go to 3, 2, 3. And so the students can visualize this. There's just so much power here of the different things that you can do. Like I did this, but maybe you don't want that stationary sine graph in there. Maybe you don't want the sine graph at all. You just want to visualize what's happening with the cosecant graph. Anything in the chat, Rachel?
I think we've mostly they're talking about the AP Precalculus Facebook group. So I think we're good right now.
Okay. All right. Let's see if I can, in some magic way, get back to the PowerPoint.
Now, one thing, as she's getting back to the PowerPoint, one thing we really want to let you know about that Transform app on the TI-84 is it's a great way to use sliders on the 84, but you do have to remember to turn it off when you are done,
Yes.
or you'll go in to do some graphing and you'll be like, why is this not working the way I thought it was going to? So at the end, it does have Quit app in your Y equals screen, and you would just select that, and then you're good to go back to normal.
All right. What are you seeing now, Rachel?
We're back to the PowerPoint point.
Okay.
Warm up and exit ticket ideas.
All right. So I think you had already talked about this one. So we'll go to the next
Okay.
screen. Okay. So this is sort of, I mean, we're kind of going backwards to some extent, but not exactly, because we wanted to show you how to graph those functions with the 84 and the Nspire. We wanted to show you a little bit with the transform app and the sliders. But this is where I would really be with my students. Once they've had a little bit of experience, I'd say, okay, let's sketch. That means paper, pencil. Let's sketch the graph of f of x equals 2 secant x plus 1. So, and then after we've sketched it, let's use our technology to check it. So, Rachel, you want to talk about, I've got 2 screenshots here. We've got one with the Nspire and one with the TI-84. So, Rachel, do you want to talk about it a little bit here?
Yeah. So when I'm reading through the Facebook posts on the AP website or like in the AP Facebook group, I think people are very thoughtful about how they teach transformations to their students. And so Vicky just shared how she would go through the transformation on this, but I'd love to see in the chat if you gave students this function 2 times the secant of x plus 1, how would you take them through thinking of these transformations? Like, what would be the first thing that you would want them to uh, think of? Like they're doing this for the first time. What would be the first thing you would want them to modify about the secant graph? And then what would you do next? So we'll give you just a moment to type into the chat, because I'm always curious what teachers are doing with this. And I think a lot of times we do have 2 different points of view because we well, we might have learned it one way or another, and there's always a good way to check it in the graphs. So we've got this idea of a table of
Okay.
values,
Looking at tables of values.
vertical
This line
dilations,
first. Yeah. Um, you know, I know that
and
when I taught this, and I taught it for a lot of years, I mean, just in a traditional pre-calc class, we taught this. I tried to emphasize helping kids understand that if our sine or our cosine function, not the 2 sine or 2 cosine, but just y equals sine of x and y equals cosine of x, those range values are between -1 and 1. What happens when you take reciprocals of numbers that are between -1 and 1? And helping them have that realization, oh, they're going to either be larger than 1 or smaller than -1, and that gives us those shapes that we see with both the secant and the cosecant graphs. I think that's helping them understand that. But then I do like your suggestion, Rachel, of thinking about what are the steps that you would go through. And so that's kind of why I like to start with the basic sine or cosine graphs.
I agree. I agree. I want them to start making sense of these maximums and minimums. I mean they're like very local maximums and minimums, but trying to connect that to what they understand about the reciprocal of the secant graph, and trying to make those connections and then working into our dilations and our shifts. Lots of good
Excellent.
ideas here in the chat.
What was it, Rachel?
Just lots and lots of ideas about different
Okay.
ways to present this to students. But I think, again, it all comes down to this idea of sense making, and we can always use our technology just to help students double check what's going on in their brains.
Okay, so I think we've got a little bit of time left. I think it's time for us to kind of move over to our inverses. I tried to talk about them a few seconds ago, but I caught myself. So I think it's really, really important that you go back to understanding some of the discussions that you had in topic 2.8. And hopefully they talked about inverses in Algebra 2 a little bit also. But the domain restrictions are so important with your inverse functions, and recalling them and realizing that, when I look at the graph, I'll never forget the first time, y'all, and I'm going way back, okay? First time we had a graphing calculator and we decided to look at, in my pre-calculus class, what the graph of y equals inverse sine of x looked like on the calculator, because all we were seeing is things in textbooks and all this kind of stuff. So we put it in the calculator and one of the kids said, "That's all we get is that little worm thing sitting right there." It kind of got nicknamed the worm for a lot of years in my classes. So I do want to point out that both notations are used, so students need to be very flexible and making sure that they understand both that. And we can argue all we want about how we like it or don't like it, but the little -1 up high for the inverse sign or using that phrase arc sign. As a matter of fact, I think on the 2024 FRQ4 question, there was one of each. There was an arc and an inverse notation symbol there. Okay, so again, we're back to the a skill that I would like students to have once they've seen these different graphs, and we will show you these in just a few minutes. But the transformations, I think they need to do some transformation. Let's see if I can spit that out. Transformations with these graphs. I don't think they need to get, ultra complex, but they definitely need to see a few of the transformations in the classroom. All right. Rachel, I'm gonna try to go to the 84 real quick.
That
All
sounds
right,
good.
there we go. All right, y
Man, that was quick.
equals. I got better with. I don't know why it didn't work the first time. I'm really perplexed to some extent. Okay, do we want to, let's just show the inverse sine function. I'm leaving it on the transform app, so we have that option right now, but I am going to go to Y3 because that is not where I would see a transformation. So notice that inverse sine, as we pointed out earlier tonight, is the blue. We've got to hit the second and sine to get inverse sine of x. I'm not sure what window we want to use. What do we want to try, Rachel? Zoom decimal, maybe?
Yeah, I really like that one on the, when in doubt, that's the one I start with on the 84.
Yeah. Notice we've got some little strange things there, but we could go in and we could do some little minor transformations. So maybe, do you want to just do a times inverse sine of x?
Yeah, that sounds like a good starting spot. And while you're typing that in, Colleen was sharing that this is one of the things, she had a really strong group of AP Pre-Calc students last year, and this was one of the things that was challenging. And I think a lot of us would say that about our students, and it's because there's so much to keep track of when you're talking about those restricted domains.
Yes. So our A right now is 3, 2. All right, we're back at 1. So here's 2. So I think it's important to point out to students that I mean, this really makes vertical stretches seem realistic and, make a lot of sense, but they do have to watch their window a little bit, because if I go up to 3, it's going to try to kind of go off the window to some extent. But I think if I go back, let's just look at slowly getting there. How do you, okay, I was looking at the thing. Chat, how do you turn the transformation app on for only some functions? You can use it with any function, but you can only put in the parameters in Y1 and Y2. I don't know if I'm answering the question though that was in the chat, Rachel.
That's how I interpret it. I'll keep an eye out for what Breck responds to
Okay.
your answer.
All right, so somebody also asked, do we need this for the exam? I think I definitely would do a little bit of the transformations. Again, I would not do complex transformations, but I think a little bit just to make sure that they can handle it if they need to. We do have at the end of the webinar a list of questions that might be that have been on the practice exams that you could like pinpoint and look at to see the different varieties of things that have been on the practice exams and last year's AP exam with the free response questions. But this is how you would do it on the 84. Again, you could demonstrate it with any of the 3 inverses. You could put in a parameter of B, you could put in a parameter of C. I don't think I would do a whole bunch of them at one time. I would if I were doing sine and cosine functions, but not with these, but I would definitely show a few of them. What's the window for inverse sine? Well, I tell you what, let's do this. Let's go to window and let's set this window a little bit a nicer way for us. So, let's see, let's do like, I don't know, Rachel, what do you think? Like -2, -3 to 3.
That sounds good. Yeah.
And
Just to
then,
kind of key in since it's
yeah, how about pi and negative pi?
nice. And just getting students to understand why we started talking about pi in our Y min and Y max now, when we've always talked about pi in terms of the x axis. I think that right there is a great conversation to have with students. And Carrie, thanks for sharing with Rohit that that was the Zoom decimal that we were in previously before we made these
Okay.
adjustments.
And it's -1, so we see that nice reflection. I think that's kind of neat to see that. Of
Excellent.
course, if I go
Yeah.
to 0, we're not going to see anything except a horizontal line, but it shows that restriction. And then, come on, 2 there. I think that shows nicely that that vertical stretch that we have there, that dilation. Okay, I really like graphing x equals sine of y. So yeah, that is an option with the Nspire that you don't exactly have with the 84, is that you can actually graph the inverse as where you've exchanged the x's and the y's. And Sean, thanks for sharing that. All right, do we need to show the Nspire? I'm looking at our time a little bit too. I guess we could show the Nspire. All right. Let's see. Let's press tab. Oh, it's bouncing back and forth between the different here. Let me just add a new graphing page. All right, add graphs. I don't know what we want to graph. Inverse. Let's do cosine.
That sounds good. Cosine hasn't felt any love in the last like 5 minutes, so it's time.
All right.
And
Window.
we got to
Let's.
hit enter so that we can see it.
Oh yes, I'm messing up again. Oh my gosh. Hang on. Enter. There we go. There's that cute little inverse cosine
Beautiful.
graph. Again, it shows those domain restrictions, and it's to me it's so interesting that the students can see that. We could go in and put again a slider in and do some transformations and different things. Yes, you can do, so somebody said you can do the x equals sine of y in parametric mode. I think that's going to depend on the level of your students, and I'm not sure all of them would be quite ready for that, but I think a really good group of students could definitely handle the parametric mode with that. Thank you for sharing that.
And Gerald, that might actually be a nice thing for Unit 4. I know not every teacher is teaching Unit 4, but parametrics are part of that unit. And this could be a nice way of kind of bringing some ideas back into students' minds. And I like that suggestion.
I do too. So do we want to do a slider here? I don't know how much time we have. I really want to make
We
sure we
have,
show you, do one of them maybe.
yeah, we have about a little over 10 minutes. So
Oh,
maybe
we're
a
okay.
very quick one. Yeah.
All right, let's move it up and down. Or somebody wanted a B while ago, didn't they?
Yeah, we wanted a horizontal shift earlier.
Okay. Well, that's going to be different, but that's a horizontal transformation. Oh, we'll still do it. All right. So what happens is I slide this. Oop, and that's 0. So it might be more fun to put some fractions in there and see it stretched a little bit. So that takes a little more setting up. Well, the sliders aren't going to work real well with the fractions, but I would probably just physically go in and put some things like, let's go tab. Let's go back up here. Let's take the B out. I would put in something like 1/3 X. All right, enter. And so that again, I think shows that sorry, I'm going to say the wrong word, horizontal stretch by a factor of 3, which is very, very nice. And then if we wanted to move it right or left a little bit, we could. So all of these are possibilities either with the sliders or just exploring them a little bit.
Yeah, Vicky, when I'm working with my students, sometimes I love the sliders. I think that's how you can see a lot of examples quickly. But if I feel like they're just playing and not trying to make sense of things, then I say, no, I want you to type in 3 values and tell me what you notice from those 3 separate values. And I think that in this world, it's super fast paced and students are used to just clicking things aimlessly sometimes. It's great to get them to slow down and be more intentional and think about what they're doing. So I love that you did a little bit of both because I think there's a place for each one of those strategies with our students.
Thank you for sharing that, Rachel. Well, I think that's actually kind of what I was trying to get at with this particular request of students to sketch and then check with your calculator, because they've got to do that vertical stretch by a factor of 3, and then they've got to realize that their graph, and that is not move the graph down 1, is it?
I'm looking at that scale because it goes down to -6 on
Yeah,
the lower y-axis. I think it is,
I
but
think I think I typed in, well, yeah, I typed in totally different something in what I intended than what I typed up there in my equation. So I apologize for that. I should have checked that more carefully. So the intent was that this should have been close parenthesis behind the X and then -1 with a vertical shift down 1 unit. So apologies on that.
Vicky, I still put that up on the screen. I say, you know what? It's find the mistake on the screen time. Like, I want you to make sense of it now.
It's a perfect opportunity. Okay, so some other kinds of things that I think are really good in working with the inverses is that students need to be able to do some evaluations. Again, I think this is a paper pencil. Let's evaluate this. Let's think about it. And then I want you to check with your calculator. The main reason I wanted to share this with you is so that you knew that you could check this with your calculator. So for students who would use the TI-84, let's just kind of talk through what's actually going on. So inverse cosine of -1/2 would be what? Where would we be wanting to look here? That would be in the second quadrant, so that would be 2 pi over 3. So then we're finding the sine of 2 pi over 3, which is square root of 3 over 2. I hope I just talked that right. So students
Right.
might not be recognizing that 0.866. I might say, I thought it was supposed to be square root of 3 over 2. So I was just showing how you could display that on the TI-84 to check that value. It turns out very nicely on and this is the TI-Nspire cast that I was doing a screen capture with. I think I don't use the numeric Nspires much, Rachel. I think it would probably be very similar to what the 84 presented with the decimal value. But you
I
can
think so
check these
too.
on the calculator. But again, this is a do it paper pencil, and then let's see what the calculator tells us. And one last question. This is very similar to what students will possibly see on FRQ4, where they're having to show some work. The question is it's not awkward, but you definitely need to read it carefully. So we're going to give you a function g that is represented as inverse sine of x over 3. We want to solve g of x equals pi over 6 for all values of x in the domain of g. I think sometimes all those words scare students a little bit, but they need to realize, oh, I've just got to set my g of x function equal to pi over 6. So over on the right-hand side, I think this is the minimal work that I would expect my students to show. They would write the equation they're going to solve. They would apply that inverse idea, and then hopefully they know the sine of pi over 6 and can solve for x. So some thoughts about how I would recommend doing this if I were to check it graphically. I would probably graph each of the two functions and find the point of intersection. And notice whether I use the TI-84 or the TI-Nspire that I get the 1.5 or the 3/2. Any questions, Rachel, or comments?
Well, there was a question that was like leading into this, not exactly about this one, but Samuel says some of my kids come to class with the hand trick when evaluating basic trig values. And Vicky, do you recommend it?
I can't remember it, so I can't teach it.
I know, I'm
One
gonna
of
have to
those
Google
people
this
that
right afterwards.
I've seen it, but it blows my mind, and I'd rather learn the values, but that's me and the way I kind of do my classes. So, all right, two quick things. Again, you can come back and rewatch this if you want to if you have access to the practice exams, though, you could actually find these when you go to the key at the end of the practice exams. So the only place we would see any of what we have talked about tonight is going to be multiple choice questions or an FRQ4. So that's primarily where you will find samples of these. So I have listed these out for you, the CED, multiple choice question 23, etc. Okay, so you can go and look at those and kind of get an idea. All right, and now we're going to have a little bit of advertising. So this was sort of a prelude. We're trying to get you accustomed to these other trig functions and the inverse trig functions so that about a week and a half from now, on February 13th, we are going to have Tom, Dick, and Steve Kokoska, and I'm the sidekick that adds little insights along the way, but some excellent problems that are going to make you think a little bit. We invite students to participate, so it's a little different from this webinar where we have students on the chat, which can get very entertaining at times, but we have some fantastic problems to go over that will take you a step further than what Rachel and I have tried to do tonight. Anything else, Rachel?
Nope, I'm just trying to get that link. I'll try to get it into the chat while
Oh, okay.
Mike does his thing, but we will make sure that
Oh, he did it.
Mike is on it all the time. I'm telling you.
All right, I'm gonna
Us are
stop
the
sharing,
best
Mike, so
people.
you can go do your thing here at the end. Who said
Colleen,
they
those
are
YouTube
recorded?
lives, yeah, they are
They
recorded,
are
so you can
recorded.
go back and watch those.
Sorry, all. I was just trying to. That was the right link.
Well, I did it all the beginning tonight. I couldn't get anything to work, so.
All right, a few people had mentioned earlier about, hey, is this calculator allowed on this exam or that exam? And this is part of the documents that you're going to get tonight. They're in my documents and not Rachel and Vicky's documents. Anyway, these are the calculators that are allowed on tests. And so you can kind of take a look at that and see what the 84 is allowed on, see what the Inspire is allowed on. So hopefully this graphic helps you clear things up. Tonight we're giving away to one lucky winner a TI graphic calculator of their choice, and it's always fun for me to give this away. Tonight's lucky winner is Monique Harris. So Monique, congratulations. Start thinking about which calculator you want to receive, and I'll be reaching out to you over email probably tomorrow to get some information from you. To receive a certificate of attendance, as well as the documents for tonight, go ahead and click the link in the chat window. And there's also a link for the certificate there as well. And if for any reason these links aren't working, just hang tight. You'll automatically get a follow-up email. That follow-up email contains even more stuff. So it's the links for the documents, the certificate, and also the recording. So you can watch this at your own pace and sort of go back through and fine-tune anything that you need to fine-tune. If you're watching this on demand, copy that link into your favorite browser to receive your certificate. When you leave the webinar, if any questions pop up that we didn't answer tonight or after the fact they pop up, give us a call or send us an email. We'd love to hear from you and love to help you. Also, when you leave the webinar, a brief survey automatically appears in your browser, and these surveys are super important to us. They really help guide us for what we're going to do in the future with all of you. So if there's something that you like that you want to see more of, let us know. If there's something that you don't like, let us know. It really does help make sure that these Tuesday nights that we're giving you what you want. Huge thanks to Rachel and Vicky for everything they shared tonight. All the documents, I know there's that page that you share with us, Vicky, and that's going to be super helpful too. So thanks so much to both of you. And thanks so much, everyone, for joining us tonight. We hope to see you back online next week. If you are an Inspire user and you have any questions about the digital SAT, let me make sure I'm not messing this up. Yep, next week is the digital SAT and TI-Nspire. So feel free to register for that and join us next Tuesday. Have a great night, everyone. Stay safe, and we will see you soon.